Um, all right. So welcome everybody to a closer look at Range C, a simplified carbon monitoring tool on rangelands. And this is presented by Point Blue Conservation Science, all of us here today. My name is Lishka Rada again, and I'm Point Blue Communications Manager. I use she, her pronouns, and I'm happy to be your host today. I am zooming in from the unceded lands of the Coast Miwok people, also known as Petaluma, California. And I'm excited to hear your questions today. I'm excited to hear how maybe you're using this tool already, how you're excited to use it. Um, and again, please do. Yeah, all right. I see some folks chiming in the chat now. Zach from Lake Berryessa, Napa County. We've got Alexis coming in from Wichita, Kansas. Awesome. So yeah, please do share where you're zooming in from in the chat, and maybe one thing that you're curious to learn about, know about from today's presentation from our speakers today. Keep that coming in the chat. Go ahead and pop over there, say hi to each other if you know each other, if you want to get to know each other. And I'm going to continue on with our introduction here. So if you are new to Point Blue, or if you would just like a reminder, we are a conservation nonprofit that works to conserve birds, other wildlife, and ecosystems through science, partnership, and outreach. And our focus is to address the twin threats of climate change and biodiversity loss through increasing the pace, scale, and impact of conservation science, and in particular, climate smart conservation, keeping that climate change aspect in context. And as we approach our 60th anniversary, which is next year, we're leaning into the concept of connected conservation to further increase and sustain conservation action and impact locally and globally. And in order to do this, we obviously need to dig into what's happening below ground. So in today's presentation, you'll hear from 3 of our soil scientists about a collaboratively developed tool called Range C to help ranchers, rangeland scientists, and land managers like many of you to measure conservation action impact by monitoring soil carbon. So let's get to know our speakers today. So speakers, when I shout your name out, please pop on to video here. So I'm excited to introduce Avalon Cook, conservation monitoring ecologist with Point Blue. Avalon focuses on scaling up carbon stewardship monitoring on working lands, bridging conservation science and land stewardship through collaboration. She develops frameworks to track ecosystem health and supports practices like restoration and grazing. Her dedication to actionable solutions makes her an invaluable resource for today's discussion. Please join me in welcoming Avalon Cook. And you can shout out some welcome comments in the chat if you like. You know, in the Zoom webinars, we don't have all the square photos of each other. And Avalon, if you want to pop on video, you can do that now so we can all say hello to you. You can
Hi,
stare.
everyone. Thanks for
There
being
you go.
here.
Yay.
I'll come back shortly.
Great. And next we've got Erica Foster, Dr. Erica Foster, Director of Soil Research and Conservation at Point Blue. Erica leads soils projects and rangeland carbon monitoring, bringing expertise in carbon dynamics and soil health. A dedicated educator and advocate for conservation, she connects science and stewardship to advance sustainability. So please, everybody, join me in welcoming Dr. Erica Foster.
Yeah, again, thanks all for joining today.
Thanks, Erica. And last but definitely not least, I'm honored to introduce Greg Richardson, Soil Carbon and Regenerative Systems Specialist at Point Blue Conservation Science. Greg leads the development of soil carbon sampling, carbon soil sampling guide, and supports farmers in aligning operations with ecological systems. With expertise in regenerative practices and a background in soil health and holistic management, Greg is also an invaluable resource to our team and to today's discussion. So please join me in welcoming Greg Richardson. And sorry, Greg, I got your title wrong there. Soil carbon specialist. That's a little bit easier to say.
You're doing great. Yeah, thank you so much, Lishka. Really good to be here.
Thank you, Greg. Yeah, you all have some nice welcomes in the chat here. Okay, so before I pass the mic to Avalon to get us started with today's presentation, I'm going to ask everybody to add your questions through the Q&A function and not the chat. So please, I'm going to leave the chat open for the duration of the presentation today. Please use the chat to make comments, to celebrate what you hear, to emphasize it, to share resources potentially. But please do put your questions in the Q&A function so that we can better track them and answer them when we circle back to the Q&A section at the end of our presentation today. Thank you so much. And with that, I'm going to pass the mic to Avalon.
Hello. Okay, I'm going to share my screen here. Oh, 1 second. Okay, sharing. Okay, let's see. Awesome. I think we're all set. Yeah, again, thank you so much for oh, am I muted? No.
You're good.
Okay, cool.
We can
Thank you.
hear ya.
Sorry.
Yeah.
All right. Thank you so much for joining everyone again. We're super excited to get the word out about this program. So many collaborators, including scientists and ranchers, have invested a lot into helping us vision this out, and build out the framework. And I know some of y'all are on the call today, so this is really fun. We're going to talk about the Range C Monitoring Program, which provides user-friendly guidance for practitioners to track changes in rangeland carbon in response to management practices over time, which is a little bit of a mouthful, but hopefully that makes some more sense. I'll just hit a quick agenda for us really quick. We'll start going over a few concepts around management as a carbon stewardship tool on rangelands, which is kind of how our team likes to frame up monitoring carbon. And then we'll talk about our framing as we identified sort of a need for more guidance around monitoring, starting with monitoring motivations and then working up from there. We'll then talk about what the Range C framework is, what makes it special, and how we think it meets the needs of land stewards and practitioners and the community at large. And then we'll walk through a little hypothetical example monitoring project, to sort of make it concrete how we can actually use the Range C framework to assess change in soil carbon over time. In this example, it'll be in response to a range planting, perennial reseeding project. So yeah, I'll pass it. Oh wait, actually, Okay, I'm going to talk about our soils team really quickly, just for some context about who we are. Lishka gave those great intros, but we're a team of 5. The soils team at Point Blue began in 2017. It was born out of the Working Lands group at Point Blue that was founded around supporting rangeland watershed health. So that's kind of where our foundation comes from. So in 2017, we started with the hiring of a single soil scientist, who some of y'all, I'm sure, know and have worked with and love. That was Chelsea Carey. So she's since moved on, but we owe the building of our team and our entire program to her. And we came out of sort of that focus on rangeland health, but now we're this team of 5, and we have, a range of expertise in ag science, soil science, ecology, monitoring. And now Dr. Erica Foster is our fearless leader. And I'm gonna pass it off to her to help us, frame it up with some concepts around stewardship.
Excellent. So I'm take us away here talking about the element of choice for today, carbon. And I want to refocus us on why exactly we're interested in carbon. Obviously, it's been a hot topic for a while. Researchers have been delving into different carbon dynamics. We're thinking about carbon in terms of climate change mitigation and sequestration. Specifically, our team uses carbon as this lens for rangeland stewardship. And so carbon flows between living things. It makes up a majority of organic materials. So we're made of carbon, plants and animals, and even soils. And so carbon can indicate productivity and ecosystem response, both to environmental changes that might affect plant growth, for example, and also management activities such as grazing. Our team is specifically focused on protecting and rebuilding carbon on the landscape because it can provide multiple benefits, both above ground in plants and below ground in soils. And so that's this icon off to to the right, with the tree and the cow, is showing a little bit about some of those multiple benefits of carbon that our team focuses on. So obviously, above ground plant biomass contains roughly 50% carbon, and it provides shade for livestock and wildlife. Obviously, forage production includes carbon and herbaceous biomass. Carbon and these roots that house carbon provide erosion resistance, and also carbon stored in above ground plant biomass also can lock away CO2 out of the atmosphere and potentially mitigate climate change. Then we also have below ground carbon that could be both in plant roots as well as in carbon stored and decomposing in soils. And so this carbon contributes both to soil structure and aggregation, or gluing different soil particles together, that can enhance water holding capacity and water infiltration. Carbon is also part of soil organic matter, and so it contributes in that way more to soil fertility. And also, as we're locking carbon away in soils out of the atmosphere, can potentially contribute to climate change mitigation as well. And so when we think about carbon, you can look at that diagram on the left here. We really like to focus around climate resilience. Yes, there's potential for climate change mitigation. There's also potential for creating systems that are healthy and functioning and resilient to changes in climate. So we both can mitigate climate and adapt to climate change. And that can look either like protecting existing carbon on rangelands, or also rebuilding carbon by increasing site productivity, for example. And so today we want to discuss how exactly carbon can be managed on rangeland systems. So as we go through our Range C protocol today, we'll be talking about specific conservation practice standards and how that are outlined through the Natural Resource Conservation Service. And so practices such as prescribed grazing, carbon amendment, and riparian restoration are often incentivized through different programs. So we'll be talking about a range of different practices on grazing landscapes today. And so as we're discussing these different management practices, there's a really big question hanging in the air still about what their impact is on carbon directly as this primary indicator of ecosystem health. And currently, programs that incentivize these practices might recommend different types of assessment, from soil health to forage productivity, at the start of practice implementation. Although programs might have a wide variety of methods across the board, and so it can be really challenging to compare results from these different protocols. And so we want to make sure that we can come in with a single framework and rethink and synchronize monitoring strategies. So the Rangeland Carbon Monitoring Program includes a range of different indicators that we can use to measure carbon. So for example, in roots or in soils or above ground carbon, we want to standardize and create baselines for the number of samples we need to take. We think really carefully about where the samples are located so we can track change over time. And we also have guidance around soil sampling depth, as well as different recommendations around lab methods. And so really this Range C is part of a broader framework that contains many different possible protocol outcomes depending on why you're interested in monitoring rangeland carbon. And so within this Range C program and framework, we cover a myriad of different reasons why you might measure carbon. So one could be for economic reasons, so thinking about yield and profitability from the carbon in forage production. Another, just I want to highlight here, another reason to measure carbon for economic reasons could be carbon markets, although this protocol is not set up for full measurement, monitoring, reporting, and verification required for markets. And so you can take baseline using Range C And you would overlay additional steps in order to participate in markets. And then we have kind of this overlay of stewardship goals as well, which could include certifications and labels or incentive payments and storytelling to consumers. And then you also might monitor for participation in demonstration networks, for example, or land trust requirements, or something as simple as asking the question, is carbon increasing or decreasing on the landscape? So how am I doing with my management? And then finally, our protocols can range all the way up to reaching scientific objectives. So including competitive grants, establishing really mechanistic understandings of carbon as well. And so we have this kind of range of protocols that can fit into the range C. And so right here, we just kind of structured these in a way where we show different monitoring objectives all the way from land ethic up to science and competitive grants. And so we've ordered these in order of less rigor that's required all the way up to more rigorous versions of our protocol. And so you can imagine, for example, for establishing the land ethic and how the land ethic is changing with management, the protocol could be much more accessible. You could have fewer sampling points across the landscape. You might look at soil carbon concentration and have really simple indicators of how your management is changing the rangeland. And then the science and competitive grants, for example, could require higher sample numbers, more expensive lab assays, and include different techniques for stratification or selecting how to sample across the landscape. And across all of these different protocols, there's a standard kind of scientific baseline that's upheld within the Range C framework across these different protocol options and monitoring objectives. And now to dive a little further into the protocol, I will pass it over to Greg.
All right, thank you, Erica. That was really terrific. So, yeah, we're here today to talk about the Range C monitoring program, and so I'm going to help to unpack what makes it distinct, and then sort of how it works. So, the Range C monitoring program has two key components that are free resources for you all to tap into and to use. The first is a guide for monitoring carbon, essentially to track how carbon levels are changing across a landscape as a result of commonly recommended rangeland management practices. And so on the screen here, you can see the Range C monitoring handbook, which is this guide, and it was released in 2023 and was generously funded by the Foundation for Food and Agricultural Research. And then the second piece of the Range C monitoring program is that we are currently building out a secure database to house this data and to help to advance kind of analysis and interpretation to support better understanding of how these management practices impact carbon both at local and regional scales. And I'll talk a little bit more about that next. Now, the Range C monitoring program is actually just one part of this larger, what we're calling the Ag C monitoring program, agricultural carbon. And so the second piece of that, we want to give a nod, is this Crop C monitoring handbook and monitoring program. So essentially, there's a rangelands component, and then there's a complementary parallel cropland component. So if you also are doing work in croplands, that's a resource that was developed and released just this year in 2024 and was funded through one of the Program for Climate Smart Commodity Grants through the USDA. So I want to pause here for a moment and just take a little bit of time to acknowledge some of the things that we think make Ag-C distinct. There are other efforts that are out there that support people through tracking, carbon on their landscape over time. But we feel like there's some kind of Avalon refer to them as superpowers that we want to highlight. And so the first one is just acknowledging that it wasn't just our team sitting down and deciding what we thought was best, but this was a highly collaborative effort. We brought together technical advisors who are really steeped in some of the scientific questions about how you put together strong sampling designs and what the right measurements are to use. And so what we did is we kind of collected their feedback, brought that to our practitioner advisors, whose organizations are represented in the logos on the right-hand side of the screen. So those represented ranchers, technical assistance providers, organizations that work with farming communities, to make sure that what we were proposing was relatively accessible and practical. So that's one piece, just kind of foundational to the building of the Range C platform. The next is that it really was designed to provide guidance that's tailored to each sort of management practice that's included. And so you can see through these icons and titles on the right, there are 8 different management practices that are featured in Range C. And these were the rangeland appropriate practices that were a part of the Healthy Soils program that's hosted by the California Department of Food and Agriculture. And the CPS numbers, just for orientation, are the NRCS conservation practice standards that are associated with each of these practices. And so you can imagine that if you were, let's say, planting a hedgerow or a windbreak, that the way that you might want to monitor for carbon in those contexts would look a little bit different than if you were applying compost more broadly or engaging in sort of prescribed grazing management relative to just like, stock grazing, kind of everything all at once. So we wanted to make sure that the recommendations that are featured in Range C are tailored to each of these practices, and even provide recommendations about how often to measure and how many samples to take for each of those conditions. The next thing is that, as Erica was talking about, there's some flexibility, or what we call fit for purpose, in the approach that you can take for your given project. So there's not a single set of measurements that you need to take to participate in Range C. It's possible to really adapt sort of our recommendations to fit the needs of your project and the context, like the budget, the time you have, that kind of thing. But there is sort of this baseline rigor, so everything sort of meets a certain quality of scientific standard that we feel like is needed to kind of put stock into, or put our confidence behind the results that come back. And so because of this flexibility, if you actually just stay on that slide for a second longer, there are all these different decision points that we call out that allow people to choose, if they want to, let's say, sample in a way that is of a little bit higher rigor and would essentially kind of what we call like a higher tier of accuracy. But in some cases that may be necessary. In other cases, it may be a better fit to do something that's a little bit less rigorous. And so to jump to the next slide now, the way that we have accommodated for this is what we've created an inference scoring system to create transparency around sort of the quality of the data, or the confidence that we can put in it. And so what we mean by inference score is it's, how much can we infer from the data? How much confidence can we put into some of the conclusions that we come to as a result of, or based on the results? And so the inference scores will go from 40 to 100. 100 is sort of the highest score that you can get. And the way that these decisions are made are kind of reflected in this sort of circular graphic near the top of the page, where you can consider how many carbon indicators you're measuring. So if you're measuring soil organic carbon in addition to, let's say, biomass measurements and inorganic carbon, the more of these indicators that you are accounting for, the greater representation of carbon on the landscape is included in your final results. So that would lead to a higher inference score. There's also the methods. So there are ways to use more sort of intensive or known to be accurate methods that sometimes can be a little more expensive or a little bit more time intensive. And so depending on how you make those decisions, that'll affect the inference score. And then finally, project design on the left in that blue section is essentially kind of referencing things like, do you have a control site in addition to the area that you are implementing this conservation practice for comparison's sake? That's a big one. Another one is, what is sort of the statistical certainty that you're looking for? So are you taking, more samples from a given site, or less? And so that will have a pretty big influence as well. Moving on to the next one. This is the last of kind of the key points that we think really make Range C distinct. And that is kind of coming back to this idea of the database and using sort of this database as a secure way to host data for multiplying the benefit from any given project by kind of having it connected to sort of a whole network or suite of different projects so that we can learn sort of faster together. And so if you look at the graphics here, the way that this generally will work is that, you could imagine yourself submitting your monitoring data, and then you're selecting what level of data sharing you are comfortable with. Once you do that, whatever selection you make, that portion of the data will be housed by Point Blue in a secure format. And then we can actually, what we're doing is we're automating the generation of reports to help with interpretation and analysis, essentially, of that data. But as more and more projects participate in this program, there's the opportunity to look not just on a project by project basis, but to really look more broadly at, well, what are our findings kind of across different landscapes, across different management practices, to try to advance sort of our understanding of the impacts of these practices and the benefits that they create, to kind of advance science and sort of general understanding across our communities. So that is what I wanted to speak to, is just why we feel like this was worth doing, is that there's some additional features here that we added on to really try to make a robust program that will offer benefit to those who participate in it. And so with that, I'm going to pass it over to Avalon to walk us through kind of a case study of how this works in practice.
Great. Thank you, Greg. Cool. I'm back. And the best way to sort of put it all together and understand how this works is just to walk through it. So I'm going to set up a little example scenario for us to kind of guide the monitoring decisions we're going to make, or that I've made in this example. When helping people walk through this process, we always like to make sure folks have like a pretty clear vision about what they want to learn and how they want their data to be used or how they want to use it. It really helps to return to that anchor throughout the process. So in this example, we're planning a CDFA Healthy Soils project to apply range planting, so perennial grass reseeding, to a 15-acre field on a ranch in Northern California. You want your monitoring project to support adaptive management decision-making and potentially regenerative marketing, so that like direct-to-consumer storytelling motivation that we sort of called out before. And your primary goal is to track changes in soil carbon stocks for soil health and climate adaptation and resilience over time. So I have chosen to make this example sort of as accessible as possible, which means we're not going to be shooting for like a super high inference score or data that could necessarily be published in a scientific journal. I want to keep it super simple. We're going to go through like the budgeting and stuff, so I want to keep this inexpensive, and just generally informative of what we're most interested in. And as we're going through it, if you have like a project that you're thinking of or a landscape that you work on, it might be nice to sort of like think about the decisions that I make and decide if they would apply to your scenario or not. Cool. So the first thing is pretty simple when it comes to designing a monitoring project. The first decision to make is just the boundaries of where we're going to monitor. The basic guidance in Range C is pretty simple. It's that the monitoring boundaries should match the extent of the practice. So in this example, this polygon on the right, let's say we're planning to spread broadcast perennial grass seed over that entire 15-acre area. So that's where we're going to monitor. That is our treated site. We also encourage folks as much as possible to monitor a business as usual control site along with the site where the practice is being implemented, is that really helps us learn a lot more about the actual impact of the practice because it helps us tease out, are the changes we're seeing due to like long-term climatic differences? Are they due to the practice itself? Although, as I'm sure you can imagine, if you're going to do that, it's important that the control site matches the treatment site in some like key ways. This means it's not always possible to find a suitable control site, but when it is, it can really boost our understanding of practice impact, so it raises the inference score a lot. So for this example, I've established that we have the same soil type across these two plots. They're pretty much the same topography. They're both like flat, lowland, sort of in this creek's floodplain. And they're close to each other, although they have a little buffer zone that sort of excludes the impact of one from the other, and they're roughly the same size. So that's the guidance that we use for selecting control sites, kind of put simply. And then this might feel a little bit obvious, but we really want to emphasize the importance of baseline monitoring. That is just starting your first round of monitoring before a new conservation practice has been implemented. Understanding baseline conditions hugely increases the interpretability of the results and really contributes to our understanding of practice impact over time. It's not, again, always possible, so it's not necessary within the framework. We've definitely had folks come to us like years into their rotational grazing plan or years after a restoration planting, wanting to track continued benefits now into the future, which is totally fine. But for our example, we're going to say that we'll do our first round of monitoring, say in the spring, and then broadcast our seed in the fall right before germinating rains. Great. So the next question is, what exactly do we want to measure? We kind of gestured earlier to this idea of different pools of carbon, different carbon indicators. What that really means within Range C, we support a suite of carbon indicators that represent the major forms that carbon can take on the landscape, plus a few what we call supporting metrics. There are these soil properties that provide really valuable context for interpreting the carbon data itself. So that's stuff like pH, texture, bulk density, which is a measurement of compaction, essentially. So for this case, for this example, I've decided we'll look at what I sort of consider the basics, which are soil organic carbon and soil bulk density. These two metrics together can help us track changes in soil carbon stocks over time, which tells us essentially how much carbon is stored in the study area. So if we get our soil organic carbon concentrations and then we also measure how compacted the soil is, that gives us a pretty good picture of how much soil carbon we're storing. If you're interested, we also provide methods for measuring changes in plant biomass over time. So that could be forage production, woody biomass if you're doing something like planting oaks. But we're not going to worry about that today just for simplicity. Great. So once you've selected your indicators, you can use the Range C handbook to select one of a couple tiered methods for measuring them. Like we mentioned before, we're really interested in providing a lot of flexibility that fit, a range of scenarios. So we provide multiple options for how exactly to measure each indicator. Generally, the tier 1 methods are the most accurate or the most precise or provide the most information. But tend to also be more expensive or more time consuming. So for here, I'm not going to go into all the different possibilities just for time, but I've chosen tier 2 for soil organic carbon and tier 1 for bulk density. This, in my experience, just provides a really good blend between cost effectiveness and just rigor and great data. So that's what I've selected for here, which then allows us to fill in a per sample cost, which you can fill in based on a quote from the service lab you've selected. Plus there's the cost of any soil sampling equipment needed for the methods we've selected, which this year is a pretty significant cost. It's going to make up actually the majority of the cost of the overall design. This would be an investment you make if you don't have any soil sampling equipment, and this is going to be something that you do, time and time again. So this would be the cost of a soil sampling auger, and then just some more measurement tools that we use for our bulk density method. And then to finish our little budget sheet here, the last thing we need to do is decide how many samples to take for each indicator. So the way that we provide guidance around sampling densities, or just simply put the number of samples you need in your study area, is through lookup tables that look like this. Ultimately, there's three factors that determine the number of samples you need. The first is the expected impact of the practice, and that's represented up here at the top of this table. You can imagine a different table for each practice that Greg showed in that grid, and that's just because we expect them to sort of impact the landscape differently over time. The second is the expected carbon variability of the study area. Basically, if it's a really flat, homogeneous area, we don't need as many samples to characterize the entire site. But if it's got a bunch of different soil types and varied terrain and different vegetation types, you need more samples to capture everything that's going on. So that's represented in this low, medium, and high here, which I'll dig into in a second. And the last part is just totally up to us. It's just a spectrum of how certain we want to be in our results. We broke this up into standard, advanced, and academic classes. So as you can see, academic certainty requires more samples than standard. This is just some terminology we use to sort of slot our recommended sampling densities into. Today, I'm going to go with the standard certainty level. Like I said, I want to give folks an example that's pretty simple and accessible. So that's why I've gone with that level. And now all we have to do to find our final sampling number is to decide how variable our study area is. We have a little checklist activity in the handbook that can help you assess the variability of your study area. For a relatively small open grassland pasture like this, they tend to come out as low variability. I've sort of trimmed down our table here for simplicity, but as you can see, it's flat. Like I said, we looked it up. It's one soil type. It's all grassland, and it's hasn't been, modified by any woody biomass interventions or anything like that. So it comes out to what we expect to be a low level of carbon variation. Great. So that means we have all the information we need to select our number of samples for the soil carbon analysis. Standard certainty is what we decided on. And then the low variability is what we sort of assess together. And then there's actually more tables for each other indicator that we selected. I've grayed out other ones that we're not considering today. But this is our soil carbon number, and then we'll just select the number in the same position for our bulk density chart. Low variability, standard certainty, they both come out to 3. So we now have all the information we need to fill in our little budgeting spreadsheet here. One thing to note is we opted to monitor both a treatment and control site. So that means that 3 is for each plot. So when you're doing your budgeting calculations, you would multiply that number by 2. And I'm going to go ahead and do the math to get a total for the project. I'm going to add so that we can sort of get an estimate of the time all of this will take. I'm going to just add 5 minutes per sample to account for the time in the field, navigating between sampling points. And then we have our 2 times the treatment control site sampling density. We'll multiply these and then add our one-time costs, and it comes out to $735 and just about 2 hours of sampling in the field. And then one thing to note about this figure is that the majority of this cost comes from this investment in equipment that I was talking about earlier. So if you need to buy that equipment, if you end up not needing to buy that equipment yourself, or if you're planning to carry this into future years of monitoring, if we subtract that cost just for the sample analyses, it comes out to $240. So one of our major goals with developing this framework is to help people make the most of their monitoring resources. Like, for example, those lookup tables are there to help people make sure that they can actually track change over time, that they've selected enough samples to be able to detect the change that they're trying to see, but also not taking more samples than they need for their particular scenario. Another way that we're trying to help folks make the most out of their monitoring resources is that we also provide guidance around resampling intervals to help ensure that when you do conduct resampling, enough time has passed that the benefits of the practice have had time to accrue to a detectable level. So for range planting, based on the data in the literature and our math around sampling densities, the recommended resampling interval is 5 years. Recommendations in the 5 to 10 year range can be kind of surprising to people. It may not feel like the most meaningful management timeline for a lot of land stewards, which is totally understandable. These are just recommendations, and we've had folks say, we're actually going to do this every 2 years just to see what we can learn, which is great. It's just important to keep in mind that monitoring more often than recommended can reduce your likelihood of detecting a change. You can also take these recommendations or your chosen resampling interval and divide out that monitoring cost over the years for like a per year investment in carbon monitoring figure. And if I take out that big equipment cost, because that won't be a repeated expense, it comes out for this recommendation to about $50 a year for monitoring. So that's just to give folks a ballpark idea. Great, so we've designed our whole monitoring plan. The handbook also includes this appendix where you can plug in all the decisions that you made, and it will calculate your inference score for you. So what we've done here together results in an inference score of 66. It takes into account the indicators we selected, the tiered methods we selected, some of the project design stuff like our baseline and our control site, and some other details that we don't have enough time to fully flesh out today. And then, so that's just a sort of a relative number for context. And then I just want to quickly acknowledge that we also provide all the protocols for the field work, recommendations for sample processing as applicable, and recommendations for service labs. And so this is all stuff that you can dive into in the handbook or in conversation with our team. So that's our little example. I've just got a couple more slides here to sort of tie together our vision for the program, what's in development, how to get involved. So I will pass it back to Erica for that. If I can get, yes, okay. All you, Erica.
Excellent. Thanks, Avalon. So I hope that gave you all just a glimpse as to what a Range C protocol could look like and the associated costs as well. And we're happy to answer more detailed questions, as Avalon said. And so I want to conclude today with our overall vision for the Range C program. So again, this Range C protocols were a massive collaborative effort, and we want to continue carrying that collaboration forward. Our main goals are to increase the usefulness of carbon monitoring for on-ranch management. So we want to ensure that we're summarizing results at the ranch scale and putting them in context of regional baselines and comparisons with data that's summarized from neighbors, for example. We also want to continue investing in technical assistance provider skill sets for carbon monitoring. We believe that through our trainings, we can offer technical assistance providers opportunities to think more critically about monitoring approaches, both within Range C and broadly across ecological monitoring for many different variables. We also want to continue to improve our understanding of conservation practices by region. And I'm sure everyone on the call works or is associated with rangeland systems and understands how variable they can be. We want to make sure that our efforts are really going into scientifically produced data that we can use and really hone in on what practices make sense for specific areas. And we also want to highlight that we're interested in working with underserved producers and areas where there is a lack of data right now. And this is a lot of locations for rangelands. We're still learning a lot as the data is coming in. And then finally, we want to make sure that Range C can inform incentive structures for conservation practice assistance. And this looks like incorporating data from all of the different projects that fall under Range C into an aggregated database, and then summarizing that and making adjustments to different policies and incentive programs as needed. And a big piece of how we're going to achieve this is through our web tools. So we're currently developing these with our informatics team here at Point Blue, and we're really excited to have different phases of our tool. And so the first user interface tool will help with project design. So Greg had mentioned those different monitoring questions that work through the Range C decision points. So those are all captured in this really nice kind of flow chart with different options and walks folks through how to design the monitoring plan. And then that will also include an inference score calculator, so we know exactly where your protocol fits in terms of more accessible or more rigorous. We'll also have this web tool record management information that both includes management history back as far as the user is interested in providing, and also management information in terms of what conservation practice you're interested in monitoring. This web tool also generates sampling points and then creates a system where you can securely submit and store and then access data. And so this tool will be launched in a beta format in early 2025, and then the full launch of the tool will be in fall of 2025. And so we're really excited to have experts working with us on that and really interested in continuing to collaborate. And so we'll be going more in depth about data sharing levels and data privacy. That's something that Point Blue takes really seriously. And we'll have an option at any given time if a user is interested in pulling their data from our system and completely deleting it, that will also be available. And finally, we want to think, forward about what could be most useful for rangeland stewards. And so we want to make sure that we have options to interpret data in different ways. And so we, again, want ranchers to be able to compare their own data set across summarized data from other locations. And so one example that just played was this interactive map that can help you to look at baselines across a single ranch. Finally, we'll take the aggregated data set and help create management support tools as possible. And we hope that others will partner with us to use the combined data set to create additional tools. Currently, our system is going to plug in to Farm OS, which is a really important collaborator of ours. Open Team uses that software to intake management data and collect information. And so our Ag-C tools will fit into that framework also. And then we want to make sure we have a really clear project cost calculator, because that can be a big question, is the amount of resources you can put into monitoring. And then finally, create training materials for both field and lab methods that are integrated as well. And currently, as Avalon mentioned, those are available online in the appendices of our protocol. And so finally, we just want to say, again, thank you so much for joining us today. And this whole Ag-C program was extremely collaborative from the start. And so we'd love to continue collaborating, and we're happy to have you continue to stay engaged and involved. We have a new landing page, this pointblue.org/ag-c, where you can download the Range C handbook and find out about upcoming events, and then also access this webinar recording. And then feel free to email us also at rangec@pointblue.org to provide feedback or ask specific questions, and potentially propose a training workshop. So feel free to look at that, scan that QR code, and that will take you directly to the webpage. So we hope that this webinar provided some clarity, or perhaps at least pique your interest in the Range C framework and protocols. And we really look forward to future collaborations to determine the impact of rangeland management on carbon over time. And essentially, we're all trying to figure out exactly which practices accrue carbon where. And we're really grateful for the input and time that folks on the call put into this framework and our team. And we hope that it continues to fill this need and serve to improve land stewardship across grazing landscapes. And now we are available to take any questions you might have. It looks like we have just a few minutes, but again, please feel free to email if you'd like to go into further detail on anything specific. Thank you.
Awesome. Excellent job, Soils team. Let's give them a round of chat applause. Yeah, why don't we all come back on screen and we'll get to these awesome questions. Probably just a couple of them in the 8 minutes we have left here. But yeah, let's go. So I just wanted to call out, we answered one question from Palayo. The question was, will the RMN protocol samples the frequency? So in RMN protocol samples soils every 3 years, will that change? Avalon answered that one. RainC and RMN were developed with different goals, and so they'll have some different systems, protocols, and recommendations. And RMN protocols are not slated to change. And a follow-up question from that, what depth are we sampling for range C? I think that's a literal depth, not
Yes,
symbolic.
not a philosophical depth. Yeah,
Yeah.
that's a great question. Yeah, so this is another place where we can introduce some flexibility. Our minimum sampling depth that we recommend is 12 inches, 30 centimeters. But folks can sample deeper, and then that will boost your inference score. You can also like split apart your depth increments if you're interested in learning what's happening at the surface differently from what's happening deeper. But these are all things that you can sort of choose based on your monitoring goals that will all sort of fit housed under the RainC framework.
Nice. Great. And again, if you have more questions from your question, please use that email and reach out to this awesome team. Next question from Lainey Siegner. In California, do you see range C levels generally rising over time or declining? And what are the practices where you see the largest, most promising gains in soil carbon levels? There's a follow-up question here, but I'll pause there.
Great. Thanks, Lainey. Thanks for joining today. So over the decade of sampling that we've done with the Rangeland Monitoring Network, we're led by our working lands team, because we have included a mega drought within that period, which shows declines in plant production and productivity, that we have seen soil carbon overall declining slightly across the state of California, but it depends on the region. And again, that's largely driven by the climate indicators. And so that's kind of the biggest pattern that we've been seeing. And we have some research papers that we can drop in the chat also that cover that. And then the most promising gains specifically, and I'll talk about California because when we started RainC, we're really focused on that geography and it applies to other rangelands easily. But our sample densities were of practice impact in those estimates. And so the practice that would store the most carbon is compost addition, and that's roughly a ton an acre or so annually. And then the lowest practice impact is from a really sparse planting, a silvopasture practice. And so that was down at 0.07 tons an acre, more or less. And so there's a wide range of practices represented, and not only does RainC offer different sample densities for those, but other practices could potentially be slated into the protocol also that have similar kind of effect sizes.
Awesome, thank you. There was a follow-up about how do we get the soil C monitoring more widely distributed amongst farmers and ranchers, and I think we're doing it now, right? This is part of it, right? But I'll let you elaborate on that follow-up question there.
Yeah, so our plan, and again, this protocol is written for technical assistance providers, and so we're going to be conducting trainings over the next 3 years in California and across the US for taps to be brought into using this protocol. And again, I think, as we mentioned, because there's this level and different levels of accessibility and rigor, that hopefully this protocol is going to be more widely adopted because there's that built-in flexibility.
Nice. Okay, question from Arushi Jatro. Thank you for the amazing presentation, Erica, Avalon, and Greg. He says, a question around sampling design. When you're deciding how many samples to choose, how do you quantify the study area variability?
I can take that if y'all want. Hi, Arushi. It's so good to hear from you. So it's always this like chicken and an egg thing where in the ideal world, we would know the perfect number of samples to take if we already knew the variability of the site. But since we haven't taken any samples yet, we don't. So this system with the little checkboxes that I sort of showed an abbreviated version of is a way of estimating or guessing what we think the variability will be based on different landscape characteristics. So if, like I said, there's a lot of soil types or there's a lot of different topography or a lot of different landscape features, we might expect there to be a larger variation in soil carbon values than a really homogeneous area. And the best way to make this like pretty accessible and user-friendly is to just sort of like slot all the possible variabilities into 3 categories. So that's sort of our version of like quantifying variability in a way that doesn't require us to have soil samples before we take soil samples. And it's a little, it's not perfect. And I also saw a question in here about whether variability scales with size, which is a really good question because we have worked on ranches that are tens of thousands of acres. And you would obviously think there should be more soil samples there. The answer is yes, like indirectly, because size is one of the criteria we use to assess variability. Although our protocol doesn't currently like directly scale like per acre, like here's the amount of soil samples you should take. So it's a factor. Also, the larger your area is, the more likely it is to follow into high variability anyways, just because you are going to capture more soil types and more different types of topography. So larger areas almost always come out as high variability through our assessment and therefore require more samples. Hope that helps.
Awesome. Thanks, Avalon. Then we've got a question from Alexis. They appreciate the presentation, informative and useful. And they're wondering, do you have any recommendations going beyond soil organic carbon, looking at complementary indicators such as forage diversity, biomass, water infiltration, etc.? Do you think the sample strategy would change? And I think Greg might take this one.
Yeah, sure, I can do that. And I'm also just noticing the time, so we're happy to continue on. But if anybody needs to drop off, I just want to thank you for taking the time to be with us and learn more about this process. And please keep in touch. In terms of thinking beyond carbon, kind of, and how you might sample for those types of additional indicators, the ones that you list are great. I think that it's sort of a question of what the goals are of your project, what you're trying to learn beyond, changes in carbon in terms of what measurements you might take. So yeah, water is important everywhere, and water infiltration, water storage capacity or holding capacity within soils are all great. I think the way that we think about sampling density or the number of samples that you would take in any of those given situations is, again, how variable you expect those numbers to be. So if, let's say, for bulk density, we generally consider that the bulk density of the topsoil, let's say the top 12 inches, is not going to be as variable as the soil carbon levels will be relative to one another. And so it may be that if you were just sampling bulk density, you wouldn't need to take as many samples across a given site because there's not going to be as much noise in the data. And so it's kind of when you look at these other metrics and consider, how many samples should you take, that same sort of line of thinking will apply. So if the vegetation, if you're, let's say, tracking above ground biomass, if it's pretty consistent across that field, then you probably don't need to make take as many samples across that field to get a good representation of that area. If it is a really diverse range of different plants and plant heights, then it may be necessary actually to come in and take more samples than you would for soil carbon. So it's really going to depend. We do provide recommendations in Range C for how many samples to take for things beyond just soil carbon, like above ground biomass, bulk density, pH, things of that nature. But going beyond what we provide, that's maybe just a little bit of framing that hopefully will be helpful. So I hope that adequately answers your question. It does kind of become one of those it depends types of situations.
Awesome. Thanks, Greg. Thank you, everybody. Man, time flies when you're having fun. Thank you, Erica, Evelyn, and Greg for putting on an amazing training and overview today. Thank you all for attending Point Blue's webinar today. Please do hop over to pointblue.org/agc to explore these resources and to sign up for the CropC webinar next week on Tuesday at the same time. And again, we do have our team is here available to discuss, to collaborate, to team up. Range C at pointblue.org. Give us a shout out and go ahead and check out pointblue.org and all the other great stuff that's going on at the organization. Thank you all so much for coming, and we look forward to chatting with you more soon.
Thanks.
Thank you, everyone.
Bye.